In this video, I'll introduce the concept of data integrity and show you some important data properties that you can use to help improve the quality of the data in your database. In a previous video on data types, you saw how all of the data that is stored in a database is associated with a data type. Using data types allow you to restrict the type of data that can be stored in a column. If you want the column to store numeric information only, you would assign one of the numeric data types to that column. Now, restricting certain types of data can help ensure the quality of the data in your database and also improve overall data integrity. Maintaining data integrity in your database guarantees the quality of that data and allows you to use the data as it was intended to be used. If you allow bad data into your tables, such as a string of characters like ABCD, where you expected a social security number, the data in your database is not going to be meaningful. Data types are one way to enforce the data integrity of your data. Another way to maintain the integrity of your data is the use of constraints. So constraints are rules or conditions that you can use to enforce the integrity of the data in your database. I've listed several types of constraints available with SQL Server. First, there's check constraints, and check constraints are used to limit the range of data that can be input into a column. Next are unique constraints, and unique constraints are used to enforce the uniqueness of the data within a particular column. So if you want all the values in a particular column for a particular table to be unique, you'd use what's called a unique constraint. We'll see that later in this video. Then there's referential integrity constraints, such as primary key or foreign key constraints. And these are used to maintain the related tables and the values to make sure that they're valid. The topic of referential integrity is not going to be discussed at length in this video, but I do cover it in the Database Design 101 series in length. First, I want to talk about check constraints. Now, one of the reasons why data types are so useful is that they help enforce data integrity in your whole database. And they do this by ensuring that your data is of the correct type. For instance, a date is a date and a number is a number. And you mitigate the possibility of having data stored in your database that is not usable. To take that one step further, you can also specify a range of values that are acceptable for that given data type. And this is called a check constraint. So let's say you have specified a date time field and you're using a date time data type. And you want to implement a check constraint that the value of that date has to be between, let's say, 1950 and 2010. You use a check constraint to make sure that the values entered are not only a date, but that they're in the acceptable range. You could also specify that if you had a column in your table that holds the price of a product, for example, that it doesn't exceed a certain dollar value. Check constraints can even be defined for multiple columns in your table by specifying them at the table level. By using check constraints, you can enforce the integrity of your data by restricting the data and helping improve quality along the way. Next, we have default definitions. Now, SQL Server specifies that each column in your table must contain a value. And this is where default definitions come into play. Default definitions define the value that is to be inserted into your table when no value is provided. So default definitions are defined on an individual column and determined during initial database design. Many of the tables that I create include a column titled Create Date. The Create Date is used to determine when the particular record was added to the database. I set up a default definition for the Create Date column to use the current date when added a new record. That way, when I insert a new record from either my application or through T-SQL, I don't need to provide a value for that Create Date column, and the current date is just inserted into the table by default. And that's using the default definition. Now remember, I do this because SQL Server requires that each column in my database contains a value. If you do happen to pass a different date for that value, where you have a default definition set up, then SQL Server would actually use the date that you passed and not the default value. So the default definitions are there to be used when no value is provided, but they can be overwritten. I mentioned a couple times that each column in your table must contain a value. But what if you don't know the value at the time you're inserting your record, or you don't have a value at all? And this is very common. Take, for example, a customer address table. Most of your customers will have an address line 1, but not all of them will have an address line 2. However, SQL Server requires that all columns in your table have a value. Well, how do we get around this? Well, SQL Server counts a null value as an acceptable value for the data in your tables. So null values are used to indicate the data that a particular field is unknown. So when a field allows null values, then a null value is considered an acceptable value for that field. Now you need to make a determination when creating your tables as to whether or not you want to allow null values for a particular field. Now you can specify either to not allow nulls or allow null values, such as the case in the address line 2 example. You may not want to allow nulls for every field, such as the email address or a phone number field, if you require contact information be gathered. Some other information may be optional, and a null value be acceptable, and you can even specify null value as your default value for that column. Now, a couple things to remember: when you're inserting records, null values can be passed as null, or if nothing is passed, the allow null definition will be treated like the default value and a null value saved to your table. So in other words, if you allow nulls on a particular column and you don't pass any data for that column when inserting a record, a null value will be saved. So working with null values presents some special challenges when working with T-SQL, and I'll highlight those in future videos when relevant. Next, we have unique constraints. Now, you may have a need to require that all your data in a particular table or column is unique. For example, you want to make sure that a primary key you've defined for a table is unique and not repeated. If your primary key is a customer ID, you want to make sure that two customers in the table don't have the same ID, or you'd run into many problems down the line. Now, one way to ensure that all that data in the table is unique is to specify an identity column. Now, identity columns are used to create unique values for every row in your table and do not need to be provided by the user application when adding the rows to that table. Identity columns are generally the primary key on that table. When designing and creating your database, one of the properties you can specify for a column is whether it is an identity or not. When you're inserting records into a table with an identity column, you don't need to pass the value for that column. A SQL Server will automatically provide a unique value to be inserted. This video discussed several properties that you can use to enforce data integrity for your database. You saw how data types and check constraints can be used to restrict the range of possible data values to be inserted. We also discussed the use of default values, nulls, and referential integrity. There are many more things to say about each of these topics that I did not cover here. I've introduced them in this video series because I think that they'll be important to know when you start interacting with your data later and you start performing updates and inserts on your tables. These topics are covered in detail in the Database Design 101 series, and these are critical to designing and creating your database. If you feel like you need some additional information on the topics discussed, or if you just like a refresher, please watch those videos in the Database Design series. This includes a video on data integrity and constraints.
You're watching another great instructional video from trainingspot.com, your IT training destination.